Hey guys, this is Mike, and this is the fifth video in the LibGDX desktop tutorial. So in the last video, we created this game state, play state, and now we're going to be creating the player. So let's first off just get rid of these print statements over here. And as someone mentioned, it's probably better to just put this init call inside the game state constructor. So back in game state constructor up here, just do init there, and then get rid of the init from here, so we don't have to keep doing that for every game state. Anyway, so yeah, let's go ahead and make a new package for all of our stuff here. Call it entities. Now, a little bit of planning goes a really long way, so first off, let's go ahead and plan how we're going to do this. Everyone hopefully knows what asteroids is, so just plan out your objects. Here we only have the four objects: the player, the spaceship, bullets, asteroids, and flying saucers. And you should ask yourself, what exactly do these four things have in common? Well, they have position, vector, position x and y, vector dx and dy, which is the direction they're headed, the direction, which is the angle they're facing, speed, how fast they're going, rotation speed, how fast they should be spinning. This is mostly for the player and the asteroids. We're going to have spinning asteroids. Size, this is the width and height, and shape. Now, we're going to be using polygons to draw all these. We're not going to use any images or textures or whatever. We're going to be hardcore and use math to draw all these. So all four of these things have these things in common. So it would only make sense to create some sort of superclass that holds all this stuff. So we're going to make this class first, called space object, and we're just going to extend off of it to create these four things. Makes our life much simpler. So first thing we want to do is create that superclass. Just call it space object. Here it's going to be again, we're going to have these 7 things: position, vector. Let's do position first. It's just protected float x and protected float y. I know there's a vector2 class, but I'm more comfortable just using x and y by itself, themselves. Vector, right? This is just dx and dy, the direction they're traveling in. We also have direction, which is the angle they're facing in. We're going to be using radians instead of degrees because radians is, I don't know, it's easier. We have speed and rotation speed. Protected float speed, how fast is this thing going? Protected float rotation speed, how fast is this thing rotating? And we have size, that's just width and height, or protected int width and protected int height. And finally, shape. This is the polygon. We're going to be using vertices to draw this stuff. Let me move this down a little bit. So this is just an array of vertices. We're going to use an array of floats, protected float array, call it shape x, float shape y, just like that. And that's going to be it for our space object. Pretty sweet. So that's going to get us started. Let's go ahead and create that player class now, player. And of course, we're going to use our space object class, so it extends space object, just like that. Sweet. So the player is going to have a couple extra things that the space object doesn't have. For one, it's going to have movement. So this is going to be private boolean left. If the left key is pressed, we're going to rotate to the left. Same thing for the right. And we also have one for up. When the up key is pressed, we want to accelerate the player forward. We're also going to have a max speed. We don't want the player to just not have any speed limit. Float acceleration, this is how fast the player accelerates. And deceleration. Technically this would more properly be called, this should be called friction, since there's no actual deceleration. This is just the thing that I use to slow the player down if the player is not accelerating. So I guess you can call it friction, doesn't matter. Float, we're gonna do that later actually. And what else do we need? That's pretty much it for now. Just the all this movement stuff. We just want to get the player movement up and running. So public player, let's go ahead and instantiate the player. Create some space down here so I can scroll down and up. So player constructor, we're gonna set the player position to the center of the screen. That's just x is equal to game.width divided by 2. Y is equal to game.width or height divided by 2. So yeah, that's pretty much it. We're also going to set these three things here. Max speed is going to be 300, and let's do acceleration. It's 200, and deceleration or friction is 10. These are all in pixels per second, by the way. So shape X. So let's do the shape now. Again, in space object we have the shape. So shape X is going to be new float 4. We're going to have a 4.4 vertex polygon. Shape Y, new float 4. So let me just go ahead and show you what the ship is going to look like. It's going to look like this. We have the 4 points up here, down here, over here, and over down here. So those 4 points, yep, are going to be it. And the way that we're going to draw the player is pretty simple. First off, we need the center of the player. That's this point here. And we're going to be using angles to find out where the other points are. These 4 points. And yeah, basically what we want to do is find the angles from the center to these points. So first off, the angle to the first point at the front of the player is going to be radians. The angle to the bottom left is going to be radians minus some angle theta, and the one on the bottom right is going to be radians plus some angle theta, and the one at the very bottom is just going to be radians minus or plus, you know, pi, since it's the exact opposite. So a little bit of trigonometry there. Should not be too bad, I hope. So yeah, we're gonna set that here. Going to create a method called private void set shape. This is just going to set all 4 vertices for our player. So the first point, first vertex, shape X and shape Y0, is the one at the top. This is the one that's at radians direction, and it's going to be 8 pixels away. So this is pretty simple. It's just X plus math utils. We're going to use LibGDX's math stuff because they have sine and cosine lookup tables. Cosine radians times 8. Shape Y is going to be Y plus math utils dot sine radians times 8. So what this pretty much means is that from the center, go to the radians angle and go 8 pixels in that direction. And that's where the first vertex is. So the second vertex is the one in the bottom left here. That's radians minus some angle. It's going to be shape X 1 is equal to X plus math utils dot cosine radians, and then like I said, minus some angle. I'm going to use 4 times pi divided by 5. And again, it's going to be 8 pixels away. So same thing with shape Y. Shape Y1 is equal to Y. Oh, this is plus. Y plus math utils dot sine radians minus 4 times pi divided by 5. Oops. What did I do here? Okay, times 8. Sweet. So that's this point here. The next point is going to be straight the opposite direction of radians. So that's pretty simple. That's just shape x2. X is equal to x plus cosine radians and then plus pi. This time it's going to be times 5. Shape y2 is equal to y plus mathutils dot sine radians plus pi times 5, which means pretty much from the center, radians, opposite direction, 5 pixels that way. And the bottom right is the final vertex. It's pretty much the same as the bottom left, except it's plus the angle, so you know, we already have it up there. This is just going to be shape x3 is equal to x plus cosine radians plus 4 times pi divided by 5 times 8. Same thing with shape y. Oops. Y plus mathutils dot sine radians times 4 or plus 4 times pi divided by 5. Can't type. Times 8. Okay. So those are the 4 vertices that we're going to use to set the player. And it should look something like that, pretty much. So yeah, that's set shape. Let's go ahead and do the movement variable methods here. Public void set left, boolean b. That's just left is equal to b. Same thing with right. Set right, boolean b. Right equals b. Public void set up, boolean b. Up equals b. So that's just the left, right, and up arrow keys. Okay, so let's get started with the 2 methods that I've always used. Update, float dt, and of course draw, except this time we're going to be using a shape renderer to draw our stuff. Go ahead and import that. So in update, this is relatively simple. First we're going to handle all of the keyboard input. First one is turning. Let's do turning first. So if left, all we're going to do is pretty much radians plus equals rotation speed times dt. Else if right, radians minus equals rotation speed times dt, just the opposite direction. So that's just turning. Remember, radians is the direction we're facing. So if we're pressing left or right, we have to change radians. And next one, accelerating. If up, this is where we start moving. And we're going to use a little bit of trigonometry here. Not too bad. dx is going to be mathutils.cosine radians. We want the spaceship to move in the radians direction by some acceleration. Same thing with y. Mathutils.sine radians times acceleration times dt. There we go. Next thing is deceleration or friction. Like I said, same thing. Float speed is going to be, let's call it, let's just call it vector. This is going to be pretty much the speed that we're traveling. So that's going to be float vec is equal to float math dot square root dx times dx plus dy times dy, Pythagorean theorem. That's the speed that we're going at, pretty much. And we're going to use that to normalize the stuff. First off, we want the deceleration to work. So if vec is greater than 0, then we want to subtract by the friction, or deceleration. Okay, never mind. So first we're going to normalize, and then we're going to multiply by the deceleration. And same thing with y. This equals dy divided by vec times deceleration times dt, pretty much. We also want to cap the speed. So if vec is greater than max speed, then we want to just set the max speed. Again, that's just normalizing. dx divided by vec, and then multiplying by magnitude, max speed, dy, max speed. Okay, that's pretty much that. So now we can actually set the point, set position. This is just x plus equals dx and y plus equals dy. Pretty simple stuff. And now we're going to draw the ship, or not draw, let's call it set shape, since that's what the method is called pretty much. We're just going to recalculate all the vertices of the ship using shape. And we're going to do one final thing. This is screen wrap. If the player goes to the left of the screen, he should come out the other side, the right side, and wrap around the screen, since that's what happens in Asteroids. So we're just going to create a function called wrap. Since every object in the game pretty much uses the wrap, player, bullet, asteroid, flying saucer, we're just going to put it in space object. So this is just going to be protected void wrap. And this is simple. If x is less than 0, x is equal to game.width. Move it to the other side. If x is greater than game.width, x is equal to 0. Same thing with y. Ooh, let me import that. There we go. If y is less than 0, y is equal to game.height. And if y is greater than game.height, y is equal to 0. So that just wraps around the screen. So that's pretty much it. That will get us started for pretty much just the movement stuff. So let's go ahead and draw this thing. First off, let's set the color. sr.setColor. We're going to be using white, which is 1111 RGB alpha. Now the way drawing works in LibGDX is pretty similar to how OpenGL does it. You have to have begin and end. So you put all the drawing operations into a single buffer, then you flush it out to the GPU. I'm not going to get into that. Just know that you have to put all your drawing stuff inside a begin. We're going to use shape type dot line here, and an end. All your drawing has to go somewhere in between these two. Anyway, so we already have the 4 points of the ship here. These 4 points. So all we have to do is draw lines from each of them, pretty much. So for int I equals 0, j is equal to what do you call this? Shapex dot length. You want it to go -1. Yeah, shapex dot length -1. And I is less than shapex dot length, and j is equal to I plus plus. There we go. So we're just going to draw the line here. This is going to be sr.line, and this is going to be from shape xi, shape yi to shape xj, shape yj. Pretty much. It's going to be it. So let's go ahead and test to see if this thing actually works. Let's go back into play state. First, we're going to need our renderer, shape renderer sr. And we're going to need a player. Import both of those. There we go. And in init, let me move this down for a sec. Okay. Init, we're just going to set up the renderer. SR is equal to new shape renderer. And player is equal to new player. I thought I imported that stuff. Oh, I forgot the new. My bad. So new shape renderer, new player. So an update, pretty simple. It's just player.update dt. And in draw, again, pretty simple, player.draw sr. So let's go ahead and see if this thing actually works. There we go. There's our player. He's facing the wrong way though. He's facing to the right. I want him to start by facing up. So let's go back into player, all the way in the constructor. Up here. So let's start off by make the player facing. Let's make the player face upwards. Again, radians is the direction that the thing is facing. So radians is equal to 3.14 pi divided by 2. I think that's facing upwards. Let's see. Yep, Okay, so there's our player, more or less. We can't do anything yet, so we're gonna add the stuff in here real quick, the keyboard input. So in update, we're gonna do handle input like that, and down here in handle input, we're just gonna, it's pretty simple, player.setLeft, game keys. Like I said before, we're gonna be using game keys from now on. Game keys.left, player.setRight, game keys.isDown, game keys.right, and player.setup, game keys.isDown, game keys.up. So that's pretty much it. That's the movement keyboard input, left, right, and up. Let's see if they work. Here we go. So left is not rotating left. That's amazing. Did I do something wrong? Okay, so back in player, public void set left. Let's see, I'm gonna do a print statement here to see if it's actually working. System.out.print left. It should print out left. Oh. Actually, we do if b here. Okay. So that works. I don't know why it's not changing. Oh, I think, okay. I did set the shape here. Radians. Set shape. XY, XY, XY. Back. Screen wrap. Draw. Shape X. Yeah, it all looks right. Does the right button work? Left, right, up? Okay, that's weird. I think I did something wrong with the DT. Let me double check. Oh, I get it. I think. Yeah, I forgot to set some stuff in the player from space object. I forgot to set these three things, radians, speed, and rotation speed. Well, I already set radians, so... wow, I can't believe I forgot that. Rotation speed is going to be 3. And, yeah, I didn't need to set speed. My bad. So back in the player constructor, you need rotation speed is 3. It was 0 before, that's why it wasn't turning. Okay, now he's turning. Left and right. So if I press up, obviously I did something wrong because the player is going psycho. Maybe I didn't do something with the acceleration correctly. Acceleration. The max speed. Did I set the max speed? Yeah, that's 300. I don't know why the player is going crazy. Max speed here. Oh! No, that's... Back is greater than max speed. Back here. Oh, my bad. I forgot. When you set the position, it's x plus equals dx times dt, and y plus equals dy times dt. That was a fail. I forgot about the float dt from update. Here, you have to put times dt for these two. So, let's check it out now. There we go. That looks better. Okay, I got it. So he's moving around, and hopefully max speed works. Yeah, okay, so the player has a speed limit now. And the player wraps are off the screen, left or right, up and down. So that's pretty cool. And eventually the player is going to stop because of the friction. So yeah, that was kind of a lot for one video. So I'm gonna end it here. Yeah, all we really did with the player is do all the movement stuff. We'll finish it up some other time, but for now I'm gonna end the video here, and yeah, so I'll see you in the next one.